Hi guys, today we're going to spend some time talking about stem and leaf plots. So I have a stem and leaf plot here for us to look at just to kind of have a review of what they are and why we use them. So this is a stem and leaf plot of grades on a test. And a stem and leaf plot just allows us to organize data in a way to be able to see where certain numbers or pieces of data fall most often, or where something occurs the least often. We also can't read a stem and leaf plot without a key. And here we're given a key that tells us that 7 in the stem and 1 as a leaf means the score 71. So here somebody scored a 71. Here's how you write it on the stem and leaf plot, and we can see that is right here, 71. So all of this row would represent every grade that was in the 70s. This row would represent all the grades in the 80s. You can see one person made a 100, 4 students scored in the 60s. A lot of times students ask, why do we need a stem and leaf plot? What's the point? A stem and leaf plot is a type of graph that helps us organize data so we can still see all the specific numbers and be able to see how often certain things occurred in a range. So here I wanted to still be able to see all the test scores, but know how many students scored in the 70s or how many students scored in the 90s. Where if I tried to put all of this on a bar graph and I had a bar for the 60s and a bar for the 70s, 80s, 90s, and 100s, I would see how many occurred, but I would not know the scores any longer by looking at just a bar graph. So this still shows me what occurred most often, but I get to keep the scores. So a teacher might use this to see how often did my students pass the test. A teacher might use it to see where did the majority of my students score. You might use it to track your grades to see where your grades are most often occurring. Am I mostly making 80s? Am I mostly making 60s? Am I mostly making 90s? Where are my scores? And then you could use that to give you an idea before you get your report card of how you're scoring in that class, because you know where your grades are falling. So now that we've looked at how we use a stem and leaf plot and kind of the why behind it, now let's make one ourselves. So you can see I have the framework for our stem and leaf plot set up here. I have a place for our stem and our leaves. I have my data here that we're going to be using. So we had 12 colored pencils that were measured in centimeters, and we're going to put that on a stem and leaf plot. Now notice I have a place for the key, but I don't have the key yet. So when you're making a stem and leaf plot, you need to pick one of the pieces of data and then use that to make your key. So we'll just use the first one, 17 2/10. Now for this stem and leaf plot, our whole numbers will be our stem and our tenths place will be our leaves. Stem and leaf plots are always based on place value. So we'll use 17 2/10, and the way we'll make our key is we'll say 17 as a stem and 2 as a leaf means 17 2/10. So now anyone who looks at our stem and leaf plot when it's complete will understand what place value the stems represent and what place value the leaves represent. Now I need to look at my data and figure out what would the lowest stem be and what would the highest stem be, because our stems will be in order from least to greatest. And I can look over here and see that I have stems that are 16s, but I don't see anything less than 16. And then my highest stem is a 19. So I need all the stems 16 through 19. I list them in order from least to greatest. Now I organize my leaves in the same way, from least to greatest. So I need everything that has a stem of 16 to be listed here. But I only list the leaf part. I don't need the decimal anymore. I just need the digit that falls in the leaf part, or here, the tenths place. So I'm looking for all of my 16s, and I'm going to make sure they're in order from least to greatest. So I can see I have a 16 4/10, 16 6/10, 16 8/10, and that's all of my 16s. So I have a 16 and 4/10, 6/10, and 8/10. 4, 6, and 8. And notice they're in order, and I didn't put commas between them. I just left a little space, and that's all you have to do. Next, I want my 17s, and I can see there are a lot of 17s. When you have a lot of data like that, it's a good idea to put them in order first before you try to put them on your stem and leaf plot so you don't miss any and so that they're in order for you. So I can look at them and see I have 17 and 2/10. I'm just going to make a quick list so we don't miss any. I don't have any 17 and 3/10. Here's a 17 and 4/10. Another 17 and 4/10. I remembered there were 2 of those. 17 and 5/10. 17 and 6/10. 17 and 7/10, and then 17 and 8/10. Now, I'm just going to use this to help me put them in order here on our stem and leaf plot. And remember, I only need the tenths places. I don't need the whole number anymore because that's my stem. So I need a 2, that's that one, a 4, and a 4. Now I have to list that 4 twice because it represents 2 pencils. So if I have a piece of data that's duplicated like this, 17 and 4/10 twice, I need to list it twice. Then I have 17 and 5/10, 6/10, 7/10, and 8/10. So now I have all of my 17s. Next I need my 18s. And I'm looking down my data. I have a 19 and I have a 19. I don't have any 18s, so I can't list any 18s on the leaves for this stem. I don't want to put a 0 to say that I have 0 pencils that are in that length, because that would mean I have a pencil that measured 18 and 0/10. So I leave it blank. If there are none, I leave that stem blank. I still list the stem so I can visually see that there were none. I just don't put any leaves there for that. Now I'm ready for 19. And I have 2 pencils that were 19 and 0/10 long. I have to put a 0 for those to know one pencil measured 19 and 0/10, another pencil measured 19 and 0/10. So that shows me both pieces of data. I want to check a couple of things and make sure my stem and leaf plot is complete. The first thing I want to check is, do I have all of my data? So there were 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 pieces of data. I want to make sure I have 12 leaves to know that I have represented all of them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I've represented all my data. I have a title so people know what my data is about. I have a key so someone looking at it knows what these numbers represent by their place value. All of my stems are in order from least to greatest, and I didn't skip any. And my leaves are in order from least to greatest. So I know my stem and leaf plot is complete. The next thing I could think about is what questions could be asked from this data. I could ask you, how many pencils were more than 17 1/2 centimeters long? And I don't want you to think, oh, I can't answer that question. There are no fractions on this stem and leaf plot, because I want you to remember that 17 and 5/10 is equal to 17 1/2. So if I've asked you how many pencils are more than 17 1/2 centimeters long, everything greater than that would be counted. This is more than 17 1/2 or 17 5/10. This one is more, this one, and this one. So I could say there are 1, 2, 3, 4, 5 pencils that are more than 17 1/2 centimeters long. I could also ask you, what's the difference between the longest pencil and the shortest pencil? Well, the longest pencil is 19 centimeters and the shortest is 16 4/10 centimeters long. So to find the difference, I would subtract.